Hello everyone, welcome to the Technogate. So we will discuss the second application of divide and conquer here, power of an element. So first of all, we will discuss without divide and conquer, and next one is with divide and conquer. And let's see what is the difference between without divide and conquer and with divide and conquer in terms of time complexity and space complexity here. Okay, so let's check here. So first of all, we will discuss without the divide and conquer. Without divide and conquer here. So we know that suppose that is 2 raised to power 3 here. So what will happen? 2 into 2 here. Okay. It means we are multiplying 2 3 times here. We multiplying 2 3 times here. So they are a raised to power n here. So a is the base, n is the power. So we'll run the loop for n times. 1 to n times here and multiply a with some variable here. So here let's suppose that is a power function is there. A comma n here. So take a loop here for I is 1 to n. Okay, loop then 1 to 3 times here. Like suppose the 2 raised to power 4 here, then 4 times here. 2 into 2 into 2 into 2 here. Okay, this one. So here 2 into 2 multiply with first time, 2 multiply second time, 2 multiply third time, 2 multiply 4 time here. So take a variable integer I here and f is a variable starting with 1 here. Okay. So here f equals to af into a here. So a will be passed here. What is the base here? And this one here. And this is a printf percentage d and f will be printed here. So this is the without divide and conquer here. Without divide and conquer here. Okay. So here a is 2 here, n is like a 3 here. So a raised to power n means 2 raised to power 3 here. So it is 2 initially, f is 1 here. So 1 into 2 is 2 here. Okay. The next is 2 into a again 4 here. The next time third time 8 here. So this is 8. This one. Okay. So it's a without divide and conquer here. Without divide and conquer here. So what is the time complexity here? What is the time complexity? So time complexity is there is a only one for loop is there. Okay. Only one for loop is there. This is only one for loop is there. So no recursive calls are there. So order of n here. Order of n here time complexity. And what about the space complexity? Space complexity is what? Here we are retrieving the value through the loop from the array, and array is a static data structure. So constant space is required. Constant space is required. What here? Order of 1. Order of 1 space is required here. Okay. This one time is order of 1, space is order of 1 here. Okay. So now this is a without divide and conquer. This is without a divide and conquer here. Okay, no recursive calls are there. Time order of n, space order of 1 here. Now let's see with divide and conquer. Okay, what are the effects will occur if we use divide and conquer? Okay, so let's check here. So with a divide and conquer. Okay, so what is the concept, what is the procedure for finding power of an element using divide and conquer here? So suppose that a raised to power n is divided. So here base is same but power will be divided here. So here a raised to power n by 2 into a raised to power n by 2 here. Okay. Okay. So a raised to power n by 2 into a raised to power n by 2 here. Okay. So every time a raised to power 16 here, suppose, so base is like in 2 here. Then 2 raised to power 8 here, 2 raised to power 8 here. Next is 2 raised to power 4 here, 2 raised to power 4 here. 2 raised to power 2 here, 2 raised to power 2 here, and 2 raised to power 1 here, 2 raised to power 1 here. Okay, so every time we divided the power here. Okay, so here there is a one approach is what, find the solution of this one and multiply with the same 2 times. Okay, find the solution for this one and multiply that solution again, that solution here, because both are same. 2 raised to power 8, 2 raised to power 8, how much time is required to execute 2 raised to power 8 here? So same here, same time required here, so multiply that value again here. Okay, so we have to consider only these n by 2 element only, and time for this one t n by 2 time required. Time is t n by 2 time is required here. So only consider n by 2 element here, only first half, second half will execute automatically here. So here let's see what will happen here. So power function is there, a comma n, a comma n is there. Okay, so here whenever we write the recursive call, always put the base condition. Okay, so here divide and conquer, definitely recursion will exist, and recursion first of all we put the base condition here. So what is the base condition here? Suppose that any base power is 1, then return that element only. 3 raised to power 1 is 3 only here. So what will happen here? If n equals to 1, then return simple a here, return a only, return a only. Okay, base only. Else what will happen? Then divide the power here. So divide n into 2 parts here. So divide here. So their midpoint is n by 2 element power here. Now again, so n becomes n by 2 here. Okay, so we again find power for a comma mid here. So after this one, they return the solutions here, and we want to store the solution. Why? Because we required for this part only, we required for this part here. So here b equals to power here, so declare like a int mid comma b here. So b equals to b into b here. So this is the with the divide and conquer here. So every time we are dividing a comma mid here, mid n by 2 here. So whenever when it returns, when n becomes 1 here, so here it returns here, and whatever the solution we are getting, multiply this 2 times, b into b here, b into b here. Okay, so let's see what is the time complexity required here. Okay, so let's see. So here for find the power 2 raised to power 3, what operation? Multiplication needed, multiplication needed here, 2 into 2 into 2 here. Okay, so let's see how many multiplications are required. So here let Tn be the number of multiplications, then what will happen? Tn is, okay, so let's see here. So here if n is 1, there is power is 1, then no need of multiplication, 0 here. So if power is 1, if n is 1, okay, then 0 multiplication are required, 0 multiplication are required. Okay, if power is more than 1, what will happen here? So this is first half. Okay, only solution we find only first half only. Okay, because the second half is same as the first half. So Tn by 2 time is required for this one. Okay, and here only one multiplication this one. So what will happen here? Tn by 2 plus 1 here. Okay, so 1 is constant, so Tn by 2 plus c here. So what is the solution of this one? We already solved this recurrence relation, order of log n, order of log n here. Okay, order of log n time is required for the with the divide and conquer, and without divide and conquer, order of n time is required. Okay, so next important thing is what? Space complexity. Okay, next thing is space complexity. So before discussing the space complexity, we solve this recurrence relation. Okay, how to solve it? So this is the approach. how to find the power of an element using divide and conquer. Okay, so let's see here. So let's see here. So T of n is T of n by 2 plus C here. This is a recurrence relation. Okay. So here put a same thing again here. So here T of n by 2 square plus C here. So what will happen here? T of n by 2 square plus 2C. Again T of n by 2 cube plus 3C. Okay, every time. Put again and again. So suppose it goes to the k times. Suppose it goes to the k times. Then what will happen here? Here T of n upon 2 raised to power k plus kc here. Okay. So your m is, so whenever it returns, when power becomes 1 here, so when it returns here and when it executed when it becomes 1 here. So always assume, so whenever you see the division in the recurrence relation, always assume what? N equals to 2 raised to power k here. So assume n equals to 2 raised to power k here. N equals to 2 raised to power k here. So what will happen here? T of 1 plus, so here we take log, both of these sides, then log n equals to k here. So k is what? Log n here. Log n into C here. So what will happen here? Order of log n. Order of log n. Okay. So this is the recurrence relation for find the power of an element here, and this is the solution. Okay. This is the time complexity here. So without divide and conquer, how much time is required? Order of n. And with the divide and conquer, order of log n time is required. Now what is the space? So space is the most important thing here. So let's see this. How much space is required here? Okay. So next one is a space complexity. So space complexity is what? I already discussed this. Space complexity is number of levels push into the stack, or number of levels in the recursive tree. Number of levels in the recursive tree. So let's see this one. 2 raised to power 16 here. So here 2 raised to power 8, 2 raised to power 8 here. 2 raised to power 4, 2 raised to power 4 here. 2 raised to power 2, 2 raised to power 2 here. 2 raised to power 1, 2 raised to power 1 here. So how many levels are there here? Okay. So number of levels in the recursive tree here. So 1, 2, 3 and 4 here. 4 levels are there. What is the value of n here? N value is 16. And number of levels are 4 only. Means there are log n levels. Okay. So number of levels in recursive tree is what here? Order of log n. Okay. Only 4 levels are inserted or pushed into the stack. 1, 2, 3, 4. So what is the time space complexity here? Order of log n here. Order of log n here. Order of log n time is required. Okay. So what is the space complexity? Order of log n space complexity is required. Number of levels 1, 2, 3, 4 levels. Okay. So this is the, what about the finding the power of an element without divide and conquer and with divide and conquer. Okay. So which one is better? So you can use any one of the things. If you see the, if with respect to time, then with the divide and conquer is best. And if you see with respect to the space, then without divide and conquer is best. So depending, okay. Here we can't conclude because somewhere time is less, somewhere space is less. Okay, so here without a divide and conquer and with a divide and conquer. So here time complexity is what? Order of n, and space complexity constant. Here time complexity is log n, here space complexity is order of log n, order of log n here.